Hello to all my viewers. This is Dr. Dhaval Maheta, and today we will understand how to do the settings of large language model parameters. The large language model responds with a sequence of tokens that makes sense given the context. Let's do the prompting to understand this. The sky is. So with the disease entry, what can be the next word with the probabilities? So I'll copy this word, copy this prompt, and you can see what it has generated for us. The sky is. The probability that the next word is blue is zero point 0.6. The probability that the next word is cloudy is zero point 0.3. The probability that the sky is clear, the probability is 0.1. So you can see here the probabilities and the word. This means that the output of large language model is influenced by the settings of it. We can configure a few parameters to get different results for prompts. Tweaking these settings are important to improve reliability and desirability of responses, and it takes a bit of experimentation to figure out the proper settings. Now, what are the parameters of large language model? We'll start with the first one, temperature, top P, top K, maximum tokens, stop sequences, frequency penalty. Temperature. In the context of language model, temperature is a parameter that controls the randomness of the generated output. A temperature close to zero would yield very conservative responses, sticking closely to what the model has learned, while a higher temperature, say around 1 or more, would allow for more randomness and creativity in the generated text. The range is 0.1 to 1. A temperature of 0.5 might produce responses that are balanced between coherence and creativity, while a temperature of zero point 0.1 would yield more conservative on-topic responses. Prompt: what are your thoughts on artificial intelligence considering its impact on society? Temperature 0.7. Explanation of the prompt. Setting LLM temperature at 0.7 brings coherence and creativity in the output. Let's copy this prompt and see the output. Control V, enter. So this output which is generated, it has got more creativity. Now you want that this text should be more fact oriented. Reduce the temperature, make it 0.1, enter. So this paragraph would be more factual. LLM temperature settings. If you want the deterministic output, you keep the temperature less than 1. If you want more creative output, you keep the temperature greater than 1. So less than 1, factual outputs would be generated. Greater than 1, random outputs will be generated. It will be more creative. So if you want to write the poem, keep the temperature greater than 1. In terms of application, we might want to use a lower temperature value for tasks like fact-based question answers to encourage more factual and concise response. For poem generation or other creative tasks, it might be beneficial to increase the temperature value. Now just see on the right hand side, you can see the decision tree. And the phrase is, my favorite food is. What is the probability of the next word? My favorite food is pizza. Its probability is 53%. Sushi is 30%. Tacos is 5%. When I set the temperature equal to 0, it will pick up the word with maximum probabilities. So my favorite food is pizza. When I go on increasing the temperature, it can also pick up the words with the lower probabilities like sushi and tacos. As more creativity, it allows for more creativity. So once again, I repeat, if you want to work on fact-based keep the temperature lower. If you want to be more creative in your output, increase the temperature. Let's see the previous example again. The sky is temperature 0. So it is a deterministic, we will get a deterministic output. Temperature equal to 1. There will be a randomness in the output. These are the words. At temperature 0, the model outputs the most likely words according to its training data. These words are directly chosen based on the probability in the model's training data without any randomness introduced. So the word which is having the maximum probability will be picked up. So model will choose the word blue as its probability is high. At temperature 1, the model outputs the most likely words according to its training data. These words are directly chosen based on their probability in the model's training data with randomness introduced. Here the randomness was not there. Here the randomness has been introduced. So model will choose the word serene as its probability is low. Top P. Top P sampling is a method used to diversify the generated output by limiting the vocabulary to the top P probability mass. This means that instead of considering all the possible words in the vocabulary, the model only considers the most likely words whose cumulative probability mass exceeds a certain threshold P. When setting a high p-value, example 0.9 or higher, the model considers a larger portion of the probability distribution for token selection. This results in more diverse and varied outputs because the model is allowed to select from a wider range of tokens, including those with lower probabilities. High p-values can lead to more creative and unexpected text as the model has a broader pool of tokens to choose from. Conversely, setting a low p-value, example 0.1 or lower, restricts the model to consider only the most probable tokens. This results in more conservative and predictable outputs as the model tends to select tokens with higher probabilities, which are more likely to be contextually relevant. Don't worry, I am going to explain the entire concept in upcoming slides. Range 0.1 to 1. Setting top P to 0.7 would generate responses from the top 70% most likely tokens, ensuring diverse but coherent responses. Prompt is, tell me a story from your childhood that's particularly memorable. Top P, that's 0.8. Explanation of the prompt. It generates a response with top P sampling using the top 80% most likely tokens for diversity. Let's copy this prompt. Control V, enter. So you can see here this story has been generated. Let's take the previous example again. The sky is, temperature is 0, top P is 0.45, temperature is 1, top P is 0.45. Now let's see what the output will be in two different scenarios. The first case, at temperature 0, there is no randomness introduced, so the output remains the same regardless of the value of P. All words with non-zero probability will be included. Let's talk about temperature is equal to 1. At temperature 1 with a top P value of 0.45. Now remember, this 0.45 is a threshold value. The model considers the cumulative probabilities of word until it reaches 0.45. So what the model will do, it will arrange the words in the decreasing order of the probability. You can see here 0.15, 0.12, 0.1, 0.08. So it starts with the most likely word blue, then adds clear, its probability, cloudy 0.1 and vast 0.08. Now you do the total of this. It has reached to 0.45. At this point, the cumulative probability is 0.45. So serine 0.07 is not included because adding it would exceed the threshold of 0.45. This means that the output might vary depending on the value of P, as it determines how many words are considered in the sampling process. Let's understand this. If I increase the top P value, more words more words will be generated in the output. If I keep top P less, less words will be generated. So let's read this thing again. This one. When setting a high p-value, the model considers a larger portion of the probability distribution for token selection. This results in more diverse and varied outputs because the model is allowed to select from a wide range of tokens. More words are there. Conversely, setting a low p-value restricts the model to consider only the most probable tokens. This results in more conservative and predictable outputs as a model tends to select tokens with higher probabilities. Top K. In top K sampling, the model considers only the top K most likely words according to the predicted probabilities. The value of K determines how many words are considered in this selection process. The key aspect of top K sampling is that it balances between randomness and predictability. By limiting the selection to the top keywords, it ensures that the generated text is coherent and relevant to the input context. However, it also introduces some variability, allowing the model to produce diverse outputs across the different generations. Range of top K. Small values ranging from 1 to 10. Using a small value of K such as 1 or 2 results in a very deterministic text generation. The model predominantly selects the most likely words at each step, leading to a high predictable output. This can be suitable for tasks where precision and coherence are paramount, such as language translation or summarization. Medium values 10 to 100. Medium values of K introduce a balance between the predictability and diversity in the generated text. With a moderate number of top words to choose from, the model has some flexibility in selecting the words while still prioritizing high probability options. This range is often suitable for generating text for general text generation tasks where a mix of coherence and creativity is desired. Large values, that is more than 100. This is 10 to 100. Larger values of K increases the randomness in text generation. With a wide range of top words to choose from, the model has more freedom to explore different possibilities, including the lower probability options. This can lead to more diverse and creative outputs, but may also result in occasionally grammatical errors or incoherence. Now let's see the difference in top P and top K. The prompt is, yesterday I went to the cinema to see a. The probable words are omelette, like, film, documental, love, and their respective probabilities. So what top P approach will do? First of all, it will arrange the words. It will arrange the words in the decreasing order of the probability. Film is having the highest probability, followed by documental, followed by omelette, followed by love, and like. You can see here. Now it will calculate the cumulative probability 0.54, adding the probability of documental 0.54 plus 0.36 gives us 0.9, then the probability of omelette 0.98, then of love 0.99, and then of like. So the total probability is 1. Now what is our threshold? Threshold is 0.95. So two words are selected, film and documental, because we have reached the threshold here. Now again, what the model will do, it will again assign the original probability to it. The film is having 0.54 and documental is 0.36, this one. So two words are selected based on the probability. Top P method selects the words on the basis of specified cumulative probability value. So here P is 0.95, which means that after summation only two words threshold has reached and the model will pick up the words film and documental. Let's talk about the top K approach. So here we have specified K is equal to 2. Very simple. It will pick up those words which are having the highest probability. Film and documental, the two words have been selected. Top K selects the words on the basis of number specified. So here K is equal to 2, which means that the model picks up the word with highest probabilities, which are film and documental. Top K, temperature is equal to 1, and top K approach. At temperature 1, with top K sampling, the probabilities are normalized, and then the model selects from top K words based on their adjusted probabilities. In this case, top 3 words are, so I have specified here K is equal to 3. So top 3 words are blue, clear and cloudy. The last two are not selected as their probabilities are less. However, since temperature introduces randomness, the actual selection from these top keywords may vary across the different samplings. So you can see here on the basis of probability how large language model generates the entire text. The probabilities. So here the prompt is Paris is the city. So it starts generating the text from here. Maximum tokens. This parameter determines the maximum token of the generated text. It's often used to control the verbosity of the model's responses and prevent it from generating overly long or rambling text. Setting a maximum token helps ensure that the generated output remains concise and focused on the prompt. Typically, maximum length of the text to be generated is specified in terms of tokens or characters, depending on the implementation. Range 1 to 2048. Setting maximum tokens to 100 would ensure that the responses are concise, while setting it to 500 might allow for more detailed responses. Prompt. Describe your ideal vacation destination in detail, but keep it concise. Maximum tokens 200. Explanation of the prompt. Limits the response to a maximum of 200 tokens for concise output. Let's copy this prompt. Control V, enter. Now if you want that more output is generated, maximum tokens 500. So you can see the output has increased. Stop sequences. A stop sequence is a string that stops the model from generating the tokens. Specifying stop sequence is another way to control the length and structure of the model's response. For example, you can tell the model to generate lists that have not more than 10 items by adding 11 as a stop sequence. Range, it is having a string value, specifies a token at which the generation should stop. Useful for generating responses up to a certain point. Setting the stop token to will specify some text or some words or some sentence here. So the setting the stop token to would generate response until the model reaches the end of its training data. Prompt. Write a poem about the beauty of the nature ending with a symphony of colors. Stop token, a symphony of colors. Explanation of the prompt. Specifies a symphony of colors as stop token to conclude the generated poem. Let's copy this prompt. Enter. So you can see here, the poem stops as soon as it reaches symphony of colors. Frequency penalty. When generating the text, language model tends to favor more common or frequently occurring words and phrases. This can sometimes lead to repetitive or generic responses, especially in scenarios where the model is asked to generate multiple responses. Frequency penalty helps mitigate this issue by penalizing the model for repeatedly generating the same tokens or phrases within a given context. By applying a penalty to the tokens that have already been generated, the model is encouraged to explore a wider range of vocabulary and produce more diverse and interesting responses. The higher the frequency penalty, the less likely a word will appear again. This setting reduces the repetition of the words in the model's responses by giving the tokens that appear more a higher penalty. Range 0 to 2 penalizes tokens based on their frequency in the output, discouraging repetitive or redundant responses. A frequency penalty of zero point 0.5 would discourage the repetition of the same phrases or words in the response. Prompt. Share your thoughts on climate change and its political situations, but try not to repeat yourself. Frequency penalty 0.6. Explanation of prompt. Penalizes repetitive tokens with a penalty factor of 0.6 to encourage diverse responses. Let's copy this prompt. So the output is generated with less repetition. Combination of parameters. Imagine you are a detective solving a murder mystery set in a futuristic city. Write a short story with a twist at the end. Temperature 0.8, maximum tokens 400, top P 0.7. Explanation of the prompt. Combines multiple parameters to guide the generation of a futuristic murder mystery story with specific length, creativity, and coherence. Let's copy this prompt. So the output is generated. Standard parameters. Tell me about your favorite book and why you love it. Now, when you don't specify anything, the model will take the standard values of this parameter. Explanation of the prompt. Model uses default parameters for generating a response without any specific constraints, resulting in a standard output. Let us copy this prompt also. So this is your output. Let's proceed further. All parameters together. You are a time traveler who just arrived in ancient Egypt. Describe your first impressions of the landscape, the people, and the culture. Keep your description concise but vivid and avoid repeating yourself or echoing the prompt. Temperature 0.7, maximum tokens 400, top P 0.8, frequency penalty 0.6, presence penalty 1.2, stop token the end. Explanation of the prompt. This prompt instructs the model to generate a description of ancient Egypt from perspective of a time traveler, balancing coherence and creativity while avoiding the repetition or echoing the prompt. It sets specific limits on length, encourages diverse and novel responses, and specifies a token, that is the end at which the generation should stop. Let's copy this prompt. So you can see here, it has generated the output of the impressions, and the output stopped as soon as the end was arrived. So this was all about settings of large language model parameters. For more videos on prompt engineering, kindly subscribe to my channel. I have also uploaded videos on data science, machine learning, and artificial intelligence. Kindly refer to my playlist. You can also follow me on different social medias, link given in the description box.